Good evening, all. Good evening. You are welcome to the tutorials with Fametandri Schoolboy. Today, we'll take a look at Physics Review Assignment 8. As usual, if I call you, come out, pick one question and solve it for us on the board. All right, let's go. Michael, come out. Come and pick one question. Number what? 1. Oh yeah. Take marker. Question number 1 says, the force F acting on the wings of an aircraft moving through an air of velocity v and density u is given by the equation F is equal to K. That this should be right P there, but it should be rho. Sorry, not P. It's P in a way, but just write it P. Just write P there. F is equal to K v raised to power x, v raised to power y, and a raised to power z, comma, where K is a dimensionless constant and A is the surface area of the wings of the aircraft. K. A. You mean A? A is the surface area of the wings of the aircraft. Full stop. Use dimensional analysis. Use dimensional analysis to determine the values of x, y, and z. Use dimensional analysis to determine the values of x, y, and z. Who can rescue Michael? Who? Huh? Come and try. You have 2 minutes to do that. I'm gonna let a manager know. Because you're not. Yeah, I'm gonna buy tickets now. I'm gonna because you're not. Ada. Once you give my car, boom, speed, boom, to go and sit down. Come and stand here. Let's review your work together. So finally, what do you get finally? That x is what? -1. Why? Okay, let's look at what she did. This is the equation, right? F is force, K is the constant, v raised to power x, raised to power y, and raised to power z. We are told to find what? A raised to power z, x, y, z. Chinna, can you see from there? Okay. Okay, now MA acceleration. Sorry, the MA is force. It's equal to distance over time, velocity. Okay, mass over volume, density, meter squared. Okay, you will bring it down to their units. We have kgm, meter per second square, okay? The meter, hope you're following. Distance per second, meter per second, okay? All over power raised power x. Kilogram, what is this? Come, what is this? What is this? Density. No. Density is not mass over velocity. What is density? Density is what? Mass over volume. I think that's where your error came from. That's where the error came from. This is what, have you seen that you can fail what you know? So we need to be careful, okay? Very, very careful. Mass per meter cube. Let's put our y. So here is what? This is what? Area. Area is what? Meter squared. Okay, let's put our z. So now, once you move to what? What is it called? This one has no unit because it can know what? Dimension. So it's gone. That's why it did not appear here again. Then here, ml per second square is equal to ml per tx. Sorry. ml per t cube is equal to y m squared is equal to z. So you open the bracket. You have this. We have this L x for x per, that is t raised to minus x dot n raised to y, because we are opening these brackets. N raised to y, n raised to y, and the t raised to minus 3y. Good. Then you open the other one. You have. Okay, thank you. Is now equal to what? Minus what? X power here, this is how it should be. So here is now m raised power what? Here should be, the second one is what? Here is m raised power y, L raised power what? 3y. No, 3y. This is 3y. Help me with this. So 3y, then this t will go. This t will go. So you have, give me, times dot m raised to power 2z. So you now come down here. You bring this down. Here is now L, you bring the like terms, all the L's, you bring them together. So you have L raised to power x, L raised to power what? Y. This is 3y now. 3y dot 3 raised to power minus x dot 3 raised to power, this, there's no need for this again. Dot 3 raised to power minus x dot m raised to power y and m raised to power what? 2z. You now come down. You now come down here. You have your L. From your law of indices, this is certain as saying L raised to power x minus y. I hope you know. I don't say stretching your neck there. Come closer now. You are far away. I say this L raised to power what? X plus what? Y, right? Good. Well, this is 3y, sorry. This is now what? 3y. From law of what? Indices. L raised to power x plus 3y. T raised to power what? Minus x. Remember, this 3 raised to power minus 3 is gone. So we have 3 raised to power what? Minus s dot m raised power what? Y plus what? 2z. So you now equate the two of them. M is equal to what? M here is equal to what? M raised power what? Y plus 2z. And L here is equal to what? L raised power what? L raised power what? S plus what? S plus what? 3y. And 3 raised power minus 2 is equal to what? 3 raised power minus 2. There's no need for this 3y again. 3 raised power minus 2 is equal to what? Minus x. So if you now come down, you have that 1 is equal to what? Y plus 2z. And equation 1. And x plus 3y is equal to what? It can be 0. It's 1 now. Where do you get 0 from? This is 1. And we have x plus what? X, where is it again? X plus 3y. X minus 3y. This is your work. It's confusing me. Let me do my own. Go and sit down. Thank you. Let me do my own. If I follow your work, I'll make another mistake. The mistake is bringing is hydra-headed head again. Let me just take it cool, step by step. Chinaya, this board. Chinaya, this board. Must come in a minute now. As soon as this board should be clean, and they will do our tutorial. Entrance I'm holding. So far you are there. Clean my board for me. Okay. So we have. I think I agree to this extent. So let me now open the bracket. Let me confirm again. This is distance over time. Meter speed. This is mass acceleration. Meter watts per second watts. Raised power x. I agree. Kilogram. This is another issue now. Another mistake occurred here. It should be 1 minus what? 3. That's what it should be. That's why as I was seeing an error raising his head, that's why I cleaned everything. You say what? You said that was what you know before. I don't understand how. You say what? So where do you have velocity to come from?
It's good, not
what are you saying now? Just take your correction and let's stop. Take your correction here, please. Density is not mass over what? Velocity. Take your correction here. Okay? When you are corrected, take it and we move on. That's how to develop. Okay? All right. So let us now start the work now. So that means m L per what? T squared is equal to, now we open this bracket, we have L raised power what? X. T raised power what minus what? X. Hope you know how we got this, right? Good. Let's continue. Then we have, let me put my bracket. I can put double, let me put my brackets. In fact, that itself should even with this dimension bracket. That is the best thing to put here. This is the best thing to put here, sir. It's also this. M what? M raised power what? Y. M raised power what? Minus 3 what? Please be responding. Don't keep quiet. You know these things now. He's responding. So we can flow. We open bracket. What should be here? Good. Y. Please participate in this thing, please. M raised power what? 2 what?
Z.
Good. 2Z. Okay. 2 what? Z. Now let's continue. We have our M L T raised to power minus 2 is now equal to what? We will try to do what? Bring all the L's in one place. Bring all the T's, L in one place. And bring all the what? All the T's in one place. So let's go. Bringing all the L's, we have that's L raised to power what? X. L raised to power what? Minus what? 3y. There's no other L here, so we close. We go to, okay, we should start with from M, but no problem. No, you confuse us. It should start from M because so that it will be aligned like here. We have M raised to power what? Y and M raised to power what? 2Z. Good. So the next one is L. So we have L raised to power what? X. L raised to power what? Minus what? 3y. We close. The last one is only T. We have 1 T. We have T raised to power what? X. We close. So here we have our ML T raised to power 2 minus 2 is equal to, using law of indices, 2 raised to power X times 3 raised to power times 3 raised to power Y is certain as saying 2 raised to power S plus what? Y. True of us. So this is certain as saying M what? M Y plus what? Z, right? M Y plus what? Z. Dot what? L what? X minus what? 3y. Dot what? 3 raised to power minus X. So, which two? Which two? Thank you. 2. 3 raised to power what? L raised to power 2Z. So here now, as you can see now, this thing and this now they now look alike, three of us. Okay, let's remove the bracket so we appreciate it. We have that M raised to power L is equal to what? M raised to power what? Y plus what? 2Z. L raised to power what? X minus what? 3y. 3 raised to power what? As you can see, that they don't look alike. Hope you know that this is not saying 1, 1. Hope you know. So you cannot equate the powers. We have that M raised to power 1 is equal to what? M raised to power what? Y plus what? Z. Comma. L raised to power what? 1 is equal to what? L raised to power what? S minus 3 what? Y. Comma. 3 raised to power minus 2 is equal to what? 3 raised to power what? X. Let's start from here. Let's equate this one simply. That is simple to solve. Huh? Is what? Where is 2? Here. Where do I already remove these 2? Don't I like 2? Okay, so we have here we have that T raised to power minus 2. I thought that I came here with marker. What happened? Okay. So we have, because T raised to power minus 2 is equal to T raised to power minus S, so we cancel the 2 T's, right? That means minus 2 is equal to what? Minus S. That implies that what? X is equal to what? 2. Is it clear? Is it clear? So we now use 2 to, anywhere we see X here, we do what? We substitute. There's X here, so let's work on this one. If you cancel this L, you have what? That minus what? That 1 is equal to what? 1 is what? X minus what? 3y. Okay? Remember that X is equal to 2. That means, this implies that 1 is equal to what? 2 minus what? 3y. Right? Which implies that 3y is equal to, minus 3y is equal to what? Something is not right here. Something is definitely not right here. I don't like this. Something is missing. Something is missing. And what is that? What is that thing that is missing? Something is missing. Something is missing here. Something is missing here. Something is missing. This is meter squared. A meter is what? L, not T. The meter is what? L, not T. L, not T. Meter is L, not T. Meter is what? L, not T. Sorry. Meter is L, not M, not L, not M. L, not M. See it here. I took it as what? I took it as what? Here should be L. But I came here and brought it here as M. Meter should be L, not M. So this thing should be L. L squared. Meter squared. Area, meter squared. L distance squared. So here should be L. They are no business with what? M. So that means L should be here. There should be L raised to power what? Please correct it. L raised to power what? 2Z. Please correct it in your book, please. There should be L here. This thing is wrong. It should be L raised to power Y. Simple. So there should be, this should be X minus what? 3Y plus what? Plus what? Plus what? 2Z. Yes. Then this one is okay because there's T here. So this one is wrong. The right thing is what? L is power what? X minus what? 3Y plus what? 2Z. So this should be what? L is power Y. And L is power 2, L is power 1. I hope you are following. L is power 1 should be what? L is power X minus what? 3Y plus what? 2Z. So that means here, this one is correct. I think I've made the correction. X is 2. So there should be what? We focus on where that there's X. Or even Y7, let's solve Y. Y is simple. From here, in fact, we should even start from here. We start from that M is, since M is equal to M raised to power 1 equal to M raised to power what? Y. M will cancel, and that means what? Y is equal to what? 1. We solve for X, simple. After we now go to what? Because if you solve this one first, and it's confusion, solve the one that is simpler, so you can get the answer, then substitute here. So we are done with M, which help us to get Y. Let's go to T, which help us to get what? X. So T raised to power minus 2 is equal to what? T raised to power minus X. T will cancel T. This implies that minus 2 is equal to what? Minus S. Minus will cancel minus. This implies that X is equal to what? 2. So we've gotten Y and the X to be 1 and 2 respectively. So let's work on L now. From this thing, L is power 1 is equal to what? L is power X minus what? 3Y plus what? 2Z. L will cancel L. This implies that 1 is equal to what? S minus 3Y plus what? 2Z. Remember, we've got Y to be 1 and S to be 2. So we substitute these values in this equation. So we have something like this. This also implies that 1 is equal to what? S is 2, right? Minus 3Y. No, Y is what again? Y is 1. Minus 3 in bracket 1 plus what? 2Z. Okay, so this is 1 is equal to 2. 3 times 1 is 3. So 2 minus 3 is plus what? 2z. Therefore, we now collect items. So this implies that 2 minus 3 is what? Minus what? 1. So 1 is equal to what? Minus 1 plus what? 2z. This also implies that 2z is equal to, this will come here, it becomes what? 2. 2z is equal to 2. We divide both sides by what? 2. This implies that z is now equal to what? 2 over what? 2, which is what? 1. So x is equal to what? 2. Y is equal to what? 1. Z is equal to what? 1. These are the values of what? X, Y, Z. If you now want to get the equation go now, the formula go, we substitute these things here and get the what? Formula. So the formula F is now equal to what? K velocity, which is what? V square what? 1. Then density is equal to what? So this is 2. 1. Then area is equal to what? Z is 1. Therefore, F is now equal to what? KV squared density times what? Area. This is the formula. This is how the formula should look like. This is long, but if you follow it well, it's long and easy. That means if you make a mistake, you will have issues with it. Hello, all together. Look at it and see where the error start from. Ada, see it here. This thing should not be M again. It has moved from unit to what? Dimension. So here should be what? Please correct it in your work. Here should be what? L. This is where the issue started from. So I took this M and call it what? Mass. And push it to mass. So this is where the issue started from. It should be L squared because we have moved to what? Dimension. I can see, come and pick your question, can see. Fast. Number 2. Number 2 says, which of the following quantities? Which of the following is a fundamental quantity? A. Speed. B. Velocity. C. Length. D. Impulse. C is what? Why is length a fundamental quantity? Because it don't have a formula. I get what?
It is from the
So give me an example of derived quantity you can get from length. Volume. Volume is what? So in terms of the dimension, volume is now what? Hello, what? Thank you. You can see that. Thank you. I like that. But they didn't hear you. Please, if I call it out here, speak to us, please. Don't speak only to me, okay? The question should be. That's why it's called review. I want to say whereby if I call a student out here, you come out boldly, talk to all of us. The way I speak to you now. If I just come here and stay here and be muttering some things to myself, do you think you'll enjoy the lecture? You will not. If I call you out, what I want you to do, if I call you out, without confidence, you come out here. Talk to us. That 1 minute you are here, talk to us. Don't be feeling, shy and I don't even know what to call it. Our next person is Chinoya, come here. Also, Kioneri. What are you eating? Food. I come and pick your question. After I continue eating, no problem. I will allow you. Just pick your question first. I did tomato, mom. Give me, open it. Question what is that? Question what? 5. All right. Let's go. Go to the board. Clean the board. Fast. Let's see how far we can go before it's time. Mister, why did you come late today? See, you are still confused as if you are what? Because you came late. Why? Why did you come late? I messed up. Why? Not communicate. See. Keep your book. I'll call for you. Don't worry. Keep your book. I'll call for you. In there. Oh yeah. Number 5 says 3 vectors. 3 vectors, 3 meters per second, not 45 degrees west. On tomorrow, once it's 4 p.m., I think there's something I want us to do now. Once it's 4 p.m. from tomorrow, we'll start with lectures. We do lectures for 1 hour, full 1 hour. Then we'll now enter review. Am I communicating? Once it's 4 p.m., even if it's 1 person, I'll start my lectures. So that under 1 hour would have gone far, covered a lot of things. Then after 5 p.m. dots, we'll stop lectures and go into review. So that before 6 p.m. we would have finished our review. And if there are set time, we can now be solving more questions until 6 p.m. I think that's what we'll do now, from tomorrow. It will take effect from tomorrow. All right, so let's go. The timetable will be as it is, so, but the first thing we'll do is what? Review for the day. You understand what I mean? The timetable will not be changed. It's the same thing, but just that I will start to review. Like tomorrow we have the first thing we have to do tomorrow is what? The assignment I gave today is biology, right? If you come tomorrow, we'll do a normal what lecture? Normal chemistry lecture. Then we'll now, after lecture, after 5 p.m., complete 1 hour, 5 p.m., we move into what? Biology review. If we finish biology review and I say time, we may have to continue with our lecture until 6 p.m., okay? Or anyhow, that's what we do now from now onwards. So we can, because I don't cry here. Oh yeah, 3 vectors, 3 meters per second, not 45 degrees west, and 12 meters per second west, and 5 meters per second south. 5 meters per second south. Act at a point. Full stop. Sketch a vector diagram. sketch a vector diagram to illustrate the given information. Sketch a vector diagram to illustrate the given information. So that's how our issue will be from tomorrow. Like tomorrow now, if you come do chemistry, after chemistry, once it's 5 p.m. we enter biology review. I think the best is after that, let's assume it's a subject we can finish on time before 6. You know, some review may not be that long. If you finish on time before what is it called, 6 p.m. Before 6 p.m. we will now do this thing. We will now continue with our lecture. If I like to, I will conclude the particular subject. We have the review for like biology tomorrow. We will continue our biology lecture. That's it tomorrow. But if it extends, let's assume before 6 p.m. we will not finish on time. Then we do what? Carry it over. The next day we will continue where we stop. Is it clear? So let's take note of that. Are you done? Come here. Stand there. 3 vectors. Please look up, please. 3 vectors, 3 meters per second. This is the magnitude and this is the what? Direction. Have you seen it now? North 45 degrees what? West. Then another one is 12 meters per second west. Another one is 5 meters per second south. Act at a point. So we are told to sketch a vector diagram from the WAEC. This is remember I told you that you should learn how to sketch what? Vector what? Diagram. Very, very important. Don't solve any vector without on your own. Whether you are asked to do it or not, you must depict it in the diagram. Vector diagram. Very important before you start solving anything. Now, I will do my own. Then you tell me if there's any error in your own, okay? Good. Let's look up. The question says, the 3 vectors, number 1 is what? First of all, draw your cardinal point, okay? Draw your what? Cardinal what? Point. Very important. Cardinal point. We have your what? North, south, what? East and what? West. This is point of origin. Call it O. Where they are acting. This is the point where 3 of them are acting. Now, the first one is 3 meters per second. The second one is 12 meters per second. And the third one is what? 5 meters per second. Please, the distance you are representing your vector with need to correspond with the magnitude of the what? Vector. See, you are 12 meters per second. They smaller than you are 3 meters per second. This is a no. Let's assume you are told to represent this with what? What is it called again? What is it called again? Using we have an analytical and multiple method scale. This is a no. Look up. Don't look at this. You are standard. Look at this place. Is a no. See, you are 12. In fact, her 12 meters per second is even half of her 3 meters per second. Then her 5 meters per second is almost is even 5 meters per second is even less than 3 meters per second. Please note these things, okay? Please note these things. Now let's look at it. First of all, look at all their magnitudes and know where to do you want to start with. If you watch, 12 meters per second is what? The highest. Let's start with it. And they said it's what? West, right? West, right? So it should move like this. It should move like this. It should what? Like this, okay? Okay? This is what? 12 what? Meters per second. Next one is what? 5 meters per second what? South, right? Next one is what? 5 meters per second what? South. south, you have, this is south, right? 5 meters. So watch out. If here is 12 meters per second, 5 meters per second should be a bit less than half of this, right? If you divide this into 2, this is half. Chidaya is not looking at the board. You can go and sit down. So you can look at the board because I know I'm on the board, so I'm not here. Sit down and be looking at the board. Now, this is half, right? So this here should be less than this half, true of us. So this thing should be somewhere here. 5 should be somewhere here. We can stop here. These are 5 watts meter per second. The next one is what? The next one is what? 3. The smallest is 3 meters per second. North 45 degrees what? West. This is north. And this is west. Remember what I told you about? You don't read from the west. You read from the major pole, either south or north. So you read north, west. So from here now, you read 545 degrees. For that thing is, here is 90, right? So 45 should be half of this, right? So you read from here. So you can trace half of this. Is 45. Remember that this is 3. So this is almost 4 of this. Divide this 12 by 4. You have 1, 2, 3, 4. So 3 should be somewhere here. One small thing like that. Bam, it's okay. China, yeah? This is what? 3 watts. And here is what? 45 watts degrees. And here is what? 45 degrees. I want to ask a question. Where should this arrowhead be? Should it be like this or like this? I say, hello, look up. This arrowhead, should it be like this or like this? Like this. Thank you. They say if they are acting at a point, you see where they're acting. So this one is north. This is what? West. This is what? South. And this is what? 45 degrees what? West. This is the vector what? The diagram of this. This is the what? Vector diagram. They are acting here. So children, let me count your errors. Magnitude, who? And this is where you put the angle. This angle should be here. And you don't even label here. If I'm to score you here over 20, do you know what you will get? 0. But the magnitude is nonsense. Even the angle, even the direction, also nonsense. It's 0 over 20. This is how people fail. Please, those writing wire, please take note of this, okay? Very important. Who is the next person? Adoya, come out. Fast. Can you hear me? I believe you come. I think it the way Unisibia came enter first before Michael, but don't problem. Michael did Kamsi. Next person will China and next person will you. One also now. In a also. And from tomorrow we start our lecture. So if you come late, you missing lectures up and down. So ensure you don't come late. Where is success? Where is success? Why? Kitchen. Child. Don't they have a table for that thing? Is she the only one that stays in that kitchen? Okay, number 4. Number 4 says, which of the following pairs of physical quantities is made up of vectors? Mesoma, what is it? Since you came here, I've been watching you. What's the problem? Your attention is not here. Alright, number 4 says, which of the following pairs of physical quantities is made up of vectors? A. Speed and displacement. B. Mass and force. C. Displacement and acceleration. D. Momentum and length. Displacement and acceleration. Thank you. Oh yeah, Chinwe, come and pick your question. Fast. Number what? Number 6. Go to the board. Clean the board fast. Number 6 says, a motorcyclist passing a road junction, moves. If you want to, if you're Ibrahim is fine. You can pick the values. You must not be writing it the way. You can pick the values and do your thing. A motorcyclist passing through a road junction, moves due west for 8 seconds. Moves due west for 8 seconds at a uniform speed of 5 meters per second. At a uniform speed of 5 meters per second. Full stop. He then moves due north. For another 6 seconds with the same speed. He then moves due north for another second with the same speed. At the end of the 6 seconds, his displacement from the road junction is 50 meters in the direction of dash. At the end of the 6 seconds, his displacement from the road junction is 50 meters in the direction of dash. Solve. A motorcyclist, passing a road junction, moves due west for 8 seconds. Moves due west for 8 seconds. At a uniform speed of 5 meters per second. Full stop. He then moves due north for another 6 seconds with the same speed. At the end of the 6 seconds, his displacement from the road junction is 50 meters in the direction of dash. Come. Show it on the board. Use your show direction. Don't worry, let us not waste time. Let me solve my own, then you compare your own with my own, then tell me where you think you committed an error, or whether and where I committed the error. Look at this question. The question says a motorcyclist passing a road moves due west for 8 seconds at a uniform speed of 5 meters per second. This is the what? A cardinal point, north, south, east, and what? West. We are told that the cyclist passing a road junction moves due west for 8 seconds. So this is the road junction, right? This is a junction. He passed this road at this point and moved west for what? 8 seconds, right? At speed of what? 5 meter per what? Second. So this is west. Due west for 8 seconds. Of course, you know, we have velocity is what? 5 what? Time is what? 8 what? Seconds. Due west. Now, the same man, on getting to the west here, he says he then did what? Move what? Due north for another 6 seconds, the same velocity. Have you seen why I don't like my student to bend down, lane? Once you are there, you will just disappear. You are there, but you're not there. It's psychological. He passed through the junction and moved due what? West. They gave us displacement, develop the displacement to be what? That means we should find this distance. Hope you know. So here it should be what? Or displacement, sorry. Displacement here now, from here to here. Distance covered from here to here is what? 5 times. Remember that this is equal to what? Velocity times what? Over what? Sorry. Velocity is what? Displacement over what? Time. So that means this is equal to what? Vt, which is time is what? Velocity is what? 5 meters per what? Seconds times time, 8 what? Seconds. 5 times 8 is what? 40 what? Meter. Do you know why I'm looking for this distance? To even know which one is what? Larger, okay? To know how to represent them. So from here to here is what? 40 what? Meters. Now, they said he moved with the same speed, but the time now is what? Not the same. If the time now is how many seconds? 6 seconds. Therefore, the distance from here to here is what? 5 meters per what? Second times what? 6 what? Seconds. Which is what? 30 what? Meter. At this point, he moves due north. There's another cardinal point here, okay? This is north, this is south, this is east, and this is what? West. He moves what? Due north. For what? 30 what? Meters. So just a bit smaller than 40. So something like this. He moves due north, something like this. A bit above the half. It's okay. You put another what? Cardinal point. Here is still what? North, south, west, and what? East. This is where the man stopped. Then ask what the displacement. They say that the displacement is what? 50 watts meter. This is the displacement. And here is what? 40 watts meter. Here is right angle triangle. Are we together? Sorry, 30. God bless you. Here is what? 30 meter. Now, hello. The direction is this angle theta. This is the mass direction of the mass displacement. The man, if you want to represent it now, the man is actually not theta degree what? West. Are we together? That's the angle. Not theta degree what? West. But you cannot find this thing without finding this angle here. Okay? So let's find angle what? This angle here. You can call it anything. You can call it alpha. Let's find this angle. Here is 30 meter, 40 meter, 50 meters. Let's find this angle. Tan alpha is equal to what? 30 meter over what? True of us. So that means alpha is actually tan inverse of what? 30 meter over what? 40 what? Meter. You say now saying tan inverse of what? Meter will cancel meter. 30 over 40 is what? 0.75. And tan inverse of 0.75 is what? 30 what? 37, right? Degrees. Is it clear? Is it clear? Good. So here is what? This angle here is what? 37 degrees. If here is 37 degrees, theta is what? Theta is what? 90 minus what? To get this theta. Our concern is this theta. That's what we need. But we need to get this before we can find this theta. So that means 37 degrees. This theta is now equal to, theta is what? 90 degree minus what? Alpha. Therefore, theta is equal to what? 90 degree minus what? Which is what? 53 what? Degrees. So we will now replace this theta with what? 15 degrees. So the mass direction is what? The mass direction is what? Not 53 degrees what? West. So if you are asked to represent what is, if you are asked now, what is the displacement of the man? The displacement of the man is simply displacement of the cyclist is simply what? 50 meter, not what? 50 degrees what? West. Here is what? Magnitude. And here is what? And here is what? Direction. And that's why it's a what? Vector what? Quantity. That's why it's a what? Vector what? Quantity. Who can solve the last question? Who can solve number 3? That's the last question here. Who can solve it? Chineke, go and solve it. Also, go and solve it. Fast. Can you solve, Chineke?
This thing that the here is 5 cm. So here, I check it. The division here, the least this thing here is 0.1. So here is 5 cm and here is 6 cm. There is 5.1, 5.2, 5.3, 5.4, 5.5, 5.6. Now stop here since the vernier scale coincide here with this one.
Where did the vernier scale start?
Here.
Where the vernier scale start?
No, it starts here, but this is where they coincide.
So what did I say about where would the main scale stop? I mean, where will you stop reading the main scale? Where the vernier scale starts. So what is the main scale now?
5.7.
Where do we stop reading the main scale? Surely before the point where the vernier scale start, right? So where the vernier scale starts?
Here now. Oh, sorry, here.
So main scale is what?
5.2.
Hey, I got you. Oh yeah. What next? Now, what is next thing to do? You have known where the main scale starts, right? Stops. Now you have also known where the main vernier scale starts. Now, what is next thing to do?
Then I will check where the.
So where did they coincide?
Here.
Count it.
4.
Where did it start?
Here.
No, start from the first one.
Here is 0.
That's it. Start from the first one. Start from that one.
0. 0.01.
No, just count division. Don't bother. Just count division. Count the calculation.
1, 2, 3.
One. Start from the beginning. 1. Start from now. 1.
1 here.
1, 2, 3.
1, 2, 3, 4, 5.
Are you sure you do that thing well?
Yes, I did it.
No, something is missing. Something is missing. Where is the original one? Let's count it. Bring the question. Fast. You miss something. I count it.
1, 2, 3, 4, 5, 6.
I count your own. So what's the answer? 5.2 what? 6 cm. How did you get it? Oh yeah, show me. 1, 2, 3, 4. Correct it now. That means here should be concerned with. Move it like this. And look, this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Then you will continue. So the answer is what? 5 on what? 2, 6. 5 on what? 2, 6. Any question? The time is 6:12 already. please tomorrow. Any question before we conclude? Any quick question before I make an answer I want to make? Any question? No question. All right, thank you very much for your attention. God bless you. I asked. Tan. We are looking for this angle. Soka Tua. Opposite over what? Adjacent. Toa. Opposite over adjacent. Tan alpha. Before we now find this one. All right, thank you very much for your attention. God bless you.